So for the second part of 2.2, we're going to be looking at something called a histogram now. When we looked at stem and leaf plots, how to describe them, we talked about center, spread, shape, and outliers. That's the same checklist. Those 4 points are what you should point out and what you should describe when you're talking about a histogram. Now, a histogram, it's going to be a bar graph that has quantitative data. And what you're going to do is you're going to see intervals, and each bar is going to represent an interval. Okay? Now, one interesting thing about a histogram is that since it's quantitative data, it's continuous. In a regular bar graph, when it's categorical data, I said you should leave spaces in between those bars. When one category ends, the next one, there's separation between the two. It's not a continuous cycle like with quantitative data, where as soon as one number ends, that next number is starting right away. In a histogram, those bars are going to be touching. The bars are going to be close together. Okay? So here's an example of one. We have percent of residents age 65 and over in the state. This is the year 2000. And you can see up top, these are labeled on the x-axis above. Okay, so you can see that this bar here is 11.0 to 11.9. Okay, 12.0 to 12.9. And these are in percentages. Okay, and this is going to be counts. Okay, counts is going up the y-axis, and what this is, we're looking at, okay, here's our data set. How many of our scores fall into each one of these intervals? So this is telling us, okay, from 12 to 12.9%. Okay, there are about, I believe this goes up to the 13. So there are 13 states that have 12 to 12.9% residents 65 or over. Okay. That goes up to the 14 for 13 to 13.9. Here we have some of the smaller ones. 5 to 5.9 only has a one state there. Okay? So these bars are representing the percentage and showing you how many people or how many states, whatever we're looking at in this situation, fall into that count. The observational unit, it's how many observational units fall into that count. Now for this, if I ask you to describe this, you're looking at the same thing. Okay? You're looking at center, spread, shape, and outliers. So if I had to estimate where the center was, okay, we have a nice peak here. So I'm going to say my center is probably from 12 to 13.9%. Okay, my spread. Okay, this time we have some outliers. We have some gaps in between here. I'm actually going to leave those outliers out. Okay, the spread I want to be the major part of my data set, so I'm going to go from 8 to 15.9%. Okay, for the shape. Okay, now again, I'm going to leave those outliers out. Okay, there's our shape there. I'm going to say that's fairly symmetric. Some people might say it's slightly skewed to the left, but only very, very slightly. So if you're going to say skewed to the left, I would suggest using that word slightly. We're allowed to do that. We're estimating here, so we're allowed to use that kind of language. Okay? But looking at this, I'm going to say this is fairly symmetric. Just abbreviate there real quick. Symmetric and outliers. Okay, we do have some outliers. There's one state that has 5 to 5.9%. Okay, we also have that 17 to 17.9%. Okay, so here's our outliers here. There's two of them in this case. Okay, and we're just looking at it because of that separation. Okay, those points probably don't fit there. If you see that separation, you're allowed to call them an outlier. So this is a histogram. Now, putting together a histogram. This was nice, it was already put together for you. Here's our data set. Speed on East High Street at 3:50 p.m. This is in miles per hour. Now, what you need to do to put together a histogram, first we're going to put together a frequency table. That's organizing our data. And what you need to do is look at your data set, decide what intervals am I going to count by. Those states, the percentages, each one was worth a percentage. 12 to 12.9, that's 1 percentage point. 13 to 13.9. Each interval is the same, and it only started with the lowest and the highest and it ended at the highest. Okay, so if I'm looking at this, my highest, well, my lowest is here at 18. My highest, I'm looking at 50 miles an hour. Okay? Now what we need to do is put together a table to organize. Okay, here's our intervals. How many fall into each interval? So if we're looking at miles per hour, our lowest is 18. So let's start with 10 to 19 miles per hour. Then we're going to have 20 to 29. Now notice how I went to 19. Okay, as soon as this interval ends, now the 20 starts. The 20 interval starts. Okay, so each one's going to be the same size. There can't be any overlap. Every value, every observation has to fall into one interval. Okay, in the States, it went from 12 to 12.9, 13 to 13.9. That 0.9 made sure that everyone fell into one interval and there was no overlap. But as soon as that 12 ended, the 13 interval started. 30 to 39, 40 to 49, and 50 to 59. Now that, right there, gives us our highest value. 50 will fall there. Now we just need to count. Okay? You're trying to figure out how many are falling into each. So this is going to be our count. Notice I go across. There's 25, 28, 32, 29, 38, 32, 19, 28, 34, 40, 42, 27, another 42, a 50, and an 18. So there's all of our points. Okay? So now this is what we're organizing. We know how tall each bar needs to be. We know what our intervals are going to be. So let's put together our graph. This is going to be, I expect yours to look a little nicer. Maybe a ruler might be possible. We're going to have to count. And our count needs to go up to 5. 1, 2, 3, 4, 5. Down here we're going to have our intervals. Now I always like to start with the low interval. And I'm just on, before on the state one, each bar had a label on top. I'm just going to label my x-axis. I'm going to start with 10, 20, 30, 40, 50, and I always go one higher. I start with my low values, and I always go one higher, because now that 50 to 59, that's this gap right here, 50, 51, 52, 53, all those values fall into there. Okay, this is miles per hour. Okay, my label is just speed. And now we just gotta make some bars. For 10 to 19, that's 2. So I'm gonna go up to my 2, and there's my bar. These bars should be touching, because as soon as 10 to 19 ends, now the 20 to 29 begins. That has to go up to 5. The 30 to 39 goes to 4. 40 to 49 goes to 3. And just 1 is in the 50. So there's a nice, beautiful graph, histogram for you. And now you can describe that. Now you know where the center is. You can look at the spread. People are traveling from 10 to 60 miles an hour, you can say. Hey, doesn't look like there's any outliers, but sometimes that can be a little deceiving. Sometimes it's better to look at multiple graphs to see what we're looking at. But there's your example of how to put together a frequency table, and then using that frequency table to quickly put together your histogram. Okay? So that's the end of 2.2. Okay? Distributions and how to describe them.